Hello, everyone, and welcome to our Twitter space on iris biometrics from Optic ID to World ID. Today, we have with us Chris Brendel and Sandro Herbig. And Chris and Sandro, you want to take just a couple minutes and introduce yourself?
For sure. Hey there, I'm Sandro. I've been working at Tools for Humanity / on the Worldcoin project for about 3.5 years. At this point, basically building the orb from the ground up, like thinking about how one should verify uniqueness or how one could verify uniqueness on a global scale, and we'll talk more about that today. Looking forward to the space.
Hello, this is Chris. I'm similar to Sandro. I've been at Worldcoin / Tools for Humanity since the very first minute of the project, and since the beginning, I'm basically focusing on the biometrics part of the whole project. I'm basically going from a simple iris image all the way back in the pipeline to the decision whether this person has already been here or not. And yeah, looking forward to the conversation.
Cool, very good. Yeah, so as typical of people involved with the Worldcoin project and Tools for Humanity, Chris and Sandro are very humble individuals, which is a couple of things I really like about them. Chris is the head of all AI and biometrics, and Sandro, I call Sandro head of all things orb. I think that's a really cool title, but Sandro is just an expert on that entire stack, hardware, software, etc. So anyway, the reason for the space today is one, we obviously talk about World ID and biometrics, design of the orb. We had a space on that. But last week, Apple announced its Vision Pro headset. And with that headset came something they call Optic ID. And that kind of has brought the conversation about iris biometrics more into the mainstream. So some people perhaps had never really thought about, iris as a way to potentially identify someone, was now beginning to realize that is a potentiality, and there's some technology around that's progressed over the past few years. So anyway, today we're going to talk some about Optic ID and World ID. We're going to talk about the differences, similarities, the use cases of the two, biometrics, and how iris recognition works in general. And then we're going to talk about privacy, because it's super important anytime you're dealing with any type biometrics. One housekeeping note before we get going. We're going to try to save a few minutes at the end for questions. So if you have those, just submit those in the Twitter thread for the space, and we'll get to as many as we can toward the end. But yeah, so with that, let's jump right in. Just to level set, Sandro, for those that might not know much about Optic ID, can you just tell us what you know about it and basically how it works?
Absolutely. So first of all, the Vision Pro are, of course, an amazing piece of technology, but that's a different one. Very excited to try them out. From a kind of biometrics or Optic ID perspective, the goggles, of course, need some form to authenticate the users, to unlock the goggles, make sure nobody can access your private data, etc., except for you. So very similar to Apple's authentication mechanisms for the iPhone. So Face ID for the present iPhones and Touch ID previously. So one question, of course, is why did they pick iris recognition for the goggles, which they now call Optic ID? It's a very Apple-style decision, really. It's they could have put a fingerprint sensor on the side or something and just reuse Touch ID technology, but that of course wouldn't be Apple. So they chose something where you basically don't need to do anything. You just put the goggles on, you open your eyes, and you authenticate that way, and it just automatically unlocks without the user having to do anything, which is very convenient, honestly. One very interesting question is how does this actually work? It's dark inside those goggles mostly, so except for the display, of course. But so how would that work, and how do you make sure also the light from the display, actually, the few that there is, doesn't interfere with the eyes, right? When you're outside and look into somebody else's eyes, there's reflections of what's around you. You wouldn't want the display to actually project a pattern on the iris. So this actually works in the infrared spectrum. If you closely look at images of the goggles, there's LEDs around the display that illuminate the eye, but those are in the infrared spectrum, so it's not visible to you. For the nerds out there, it's likely 940 nanometers, similar to a security camera, for example, that can see in the dark. So that's how they work. They just take a picture in the infrared spectrum, as soon as you open your eyes.
Okay. All right, excellent. Yeah, it's a really good overview. Thank you for that. So basically, they're comparing, again, Sandro, to use an example you referenced. It's kind of like like most phones now can open with just looking at your face, kind of Face ID, as Apple calls it. I think so. It's comparing your face. We'll talk a little bit about this more in detail in a moment, but it's comparing your face in the case of a phone, or in the case of Optic ID in the headset. It's comparing your iris or your face to something that's stored in the case of the phone or the headset to make sure it authenticates you that way. Is that kind of correct to sum it up?
Yes.
Okay, cool. All right. So very good. So that's Optic ID, the basics there. So let's dig a little bit deeper into iris recognition in general, which kind of, Chris, that's your area of expertise. So can you walk us through the basics of like iris recognition? Because probably most of us that are adults have had some kind of eye exam at some level in the past, but can you walk us through the basics of like just iris recognition in general?
Sure. First of all, maybe let me separate this question into two things. And first of all, answer the question, what actually is the iris? Because that's also quite confusing to a lot of people. So the iris is actually this little colorful organ, which is on top of your eye that essentially there to control the pupil dilation. So you can think of it as this little ring muscle on your eyeball that just makes the pupil shrink. And just as a side note, please don't confuse this with the retina. I'm reading this over and over on Twitter that Worldcoin is scanning your retina. That's not true. The retina is inside your eyeball, and we don't capture that one. But yeah, what makes this iris so special? And well, it turns out that if you take a closer look on the iris, and if you do this in the right spectrum, as Sandro mentioned, like in an IR illumination, it turns out that there is a very rich pattern of small holes, like some zigzag shapes, some lines and ridges, and sometimes like even like little pigmented spots on your iris. So overall, it's a very complicated and also very random structure. And what I emphasize here is like the randomness of this texture of the iris. It is actually so random that the two irises from two different people look completely different. And in fact, even like two irises from the same person, so like my left iris and my right iris, maybe apart from color, they are completely different. And this is essentially actually the one important property that people use when they apply iris recognition. So maybe let's just quickly go through this algorithm and basically go through the conceptual steps that we take here. And it's actually very simple. So first of all, what you do is you obviously capture a very good image of an iris of a good quality, which basically means you try to avoid the user blinking while you capture the iris. You try to avoid images where the user is off gazing and so on and so forth. Next, once you basically have one good image of the user's iris, you try to locate the iris in this overall image. So basically, you want to identify which pixel of the image does belong to the iris texture and which one doesn't. For instance, there are also reflections in there, there are eyelashes in there, there is like this sclera in the pupil and all other sorts of things that you all need to segment out. So you basically only extract the iris texture, not more than that, because all the other information is basically useless for the whole algorithm. And once you've done that, you just quantify the iris texture. And I don't want to go into too much detail in there because there's a nice blog post on our website on how that works technically. But essentially what we're doing is like that we take like some special designed filters that we convolve over the iris texture, and we basically read out what are the frequencies at different positions and locations of this iris texture, and we basically quantize those, what we call responses, filter responses, into bits and just concatenate them. And in the end, what the outcome is basically something that is called an iris code in the community. And you can really think of it like as a kind of a QR code that basically is a mathematical representation of the iris texture. And the cool thing now on this iris code is that you can calculate the difference of two iris codes, or the distance of them. You take iris code A, you calculate the distance from iris code A to iris code B, which is a number between 0 and 1. 0 means they're identical, 1 means that they're completely opposite. And then you just assign a threshold and say once the difference between two iris codes is maybe above 0.3 or so, and then you can say, okay, this is definitely not the same. This iris code is definitely not from the same iris, and therefore it's a different person. And that's actually the overall algorithm. It's fairly simple. And of course, the devil is in the detail, and you need to do a lot of things right in order to make it work. But yeah, conceptually, it's fairly easy.
All right, very good. And for those, I mean, to be honest with you, when I joined the Worldcoin project, I'd never had a reason to really dig into the anatomy of the eye or specifically the iris or anything. But obviously, since I've been here for a bit, I've kind of learned a few things about it. And one thing just went out, like, first of all, Chris referenced a great article on our blog, worldcoin.org/blog, and it's iris recognition inference. So if you're interested in the details, it's all in there, and it's a really excellent article. But the technique of creating an iris code from an iris image was actually the concept, or the technique came up in a paper written by John Dogman in 1993. So this is not like a brand new concept that we invented or anything. So it's been improved upon, of course, but iris code is not a term that we coined in any kind of way. And the basic techniques are described in that paper, which is linked out of our blog post, by the way. Yeah, so that's kind of the main thing. So we talked about Optic ID, World ID a little bit. They're both similar in that they use iris recognition, which we just talked about. But in the case of, in the case of Apple and the Worldcoin project, so how is iris recognition used? We touched a little bit on that when we talked about Optic ID in detail. It's authentication. But Chris, can you walk us through those different use cases of authentication versus kind of what we do around uniqueness verification?
Sure. So maybe let's start with Apple and what they are doing. You already mentioned that they're doing what people call the one-to-one authentication. Now, how does that work? Basically, you take your goggles for the first time and you set them up, and then you basically first enroll yourself to the system, basically to this device. What basically happens under the hood is that the device takes an image of your iris, calculates an iris code or something similar, something that we don't quite know what Apple is using here, and then you store this iris code / iris template on the device. And then when you use this device a second time and you want to unlock it, it captures again an image of your iris and generates a new iris code and compares this new iris code with the one stored on the device. And if they both match, the device is unlocked, similar as you know it from like Face ID from your iPhone. So what essentially is happening is a one-to-one comparison. And as I already said, it's extremely similar to what Apple has done with Face ID and Touch ID. They just added a third biometric identifier to their port, which is iris in this case. Now, our use case and our goal is totally different. What we want to build is this proof of personhood mechanism. And for that, you need something which is called a one-to-N identification. So let's go through this step by step. So first, when you come to an orb to sign up for Worldcoin, what the orb does, it basically also captures an image of your iris, it calculates your iris code, and if there is no iris code that your iris code matches with, you're successfully signed up. So basically what we are always doing is basically a one-to-N comparison, which of course has completely different requirements on accuracy depending on how large this N in the one-to-N comparison gets. So essentially you have N times less room for doing any mistake. And that's basically the difference between a one-to-N identification and a one-to-one authentication.
Okay, very good. And I want to tie this back into when we were talking about iris codes, for example, right before this, and kind of the comparison. Chris, you mentioned we have an iris code, which is let's just simplify and call it like a digital representation of the uniqueness of your iris. And we need to do a comparison of that iris code with others that we've seen in the past. And that's kind of the one-to-N that you just described. And you referenced something when you talked about that called essentially distance. And some people may not be familiar with, people think of comparisons like, does A equal B, right? Like equality. But can you describe a distance comparison for people that may not be quite familiar with that?
Yes, of course. So unfortunately, we do not have a black or white. We rather have a distance. So it's not a Boolean value. It's like really a number. So it's two iris codes are like, the distance of them is like 0.3 or whatever. Now, what do we do for that to make it into a Boolean value, so equal or not equal? We just assign a threshold. And of course, you can set threshold depending on what your use case is. And for us, we designed the threshold to work on an optimal sweet spot for our use case. And then we simply say, okay, if the distance is larger than a certain threshold, we map the distance to like not equal. When the distance is smaller than the certain threshold, we map it to iris codes are actually equal. And it's as simple as that. Does that answer the question?
Yeah, I think so. Yeah. I think that clarified it. It's pretty straightforward. And again, our blog post talks about that in great detail too, if you're interested in more of the details. Yeah, so we're going to take this kind of as background, and we're going to shift gears and talk a bit about our mission, global proof of personhood. But before we do, just a quick reminder, if you have any questions for us, just put them in the thread, the Twitter Space thread, and we'll save a few minutes at the end to get to as many of those as we can. So now let's shift and we'll talk about proof of personhood protocol. So Sandro, can you tell us roughly what global proof of personhood is and how biometrics play into that?
Absolutely. So like going one step back even, and like thinking about like where is the internet like going to go with the advance of artificial intelligence? And I think that recently became a lot more clear just how large the impact is going to be where ChatGPT was released. It's becoming increasingly challenging to distinguish increasingly capable AI models from humans online. It's like when we're in person, like, of course, it's very obvious. I know that, like, yeah, here's a human standing next to me. Online, this is actually really hard. Based on text already today and in the future, even Zoom calls, it will become quite difficult. Actually, interestingly, like literally Apple with their goggles also released kind of this AI avatar, which is a nice word for word what was previously called like a deep fake, basically. It's like it becomes really hard to distinguish humans from AI. So this is one question that will become increasingly important going forward. A second one is like, how should the governance over such models work? And I think there's a lot of conceptual work that needs to be done. And one idea there is, okay, it's like, could we govern them similar to how we govern like democracies today? Could you just have democratic governance over them? And then the last question related to AI is that as the models become increasingly powerful, they will become increasingly useful for people and therefore likely generate unprecedented amounts of revenue, basically. And one very interesting idea and probably very important idea there is, how could we distribute some of those profits globally? Could we give it back to the people globally in the UBI-like mechanism? And at the core of all those three very fundamental questions of where like the internet and really the world is heading with AI is the notion of proof of personhood. It's like, how do you distinguish a human online from a bot? And how do you make sure somebody is actually unique? When you think about governance and receiving benefits, you want to make sure everybody can only register once for them and that no bots can register. So it's really that notion of humanness and uniqueness, and proving that globally, giving people means, empower them to prove that globally is actually a really hard technical challenge. And biometrics are fundamentally one way to solve that.
Perfect. And a perfect lead into our next topic, which happens to be one of my favorites to discuss, is, and again, we've had a Twitter space on the orb and the design, et cetera. So if you're interested in a lot of details there, you can check that out. I'm pretty sure it's recorded and linked off our account somewhere. But at any rate, let's talk about the tech involved in being able to achieve the global scale that you just mentioned. So Sandro, can you walk us through, like, how did we identify the need for biometrics in the first place, some of the rationale, key technologies, challenges of the orb, et cetera?
Yeah, so when TFH or like people at Tools for Humanity started thinking about like how could this problem be solved? So Chris and I, we sat down in an apartment one day and we just started brainstorming, okay, how could you solve this from first principles? Like, what ways are there to verify humans in a digital manner that is secure? and globally, which makes it really hard. The first thing, of course, that people think about is saying, okay, like we already have some, or many of us already have some kind of ID. But then when you think about it on a global scale, there's actually less than 50% of all people globally who have digitally verifiable IDs, which is, of course, a very big problem. If you want to build a mechanism that empowers everyone to prove their personhood online, that's a problem if more than 50% can't participate. So that doesn't work. Then there's a concept that people call web of trust, where people endorse each other, etc., and you use other forms of like social credentials. And it's an incredibly beautiful and very elegant mechanism in theory. But everyone that we talked to said it basically breaks down in practice. Nobody figured out a way to make it work. And we thought about it too, spent quite a bit of brain power on it, but couldn't figure out a way. So really the only thing that we were left with was biometrics. And just like per definition, biometrics are actually like all the unique and reproducible physical features of a person that can be measured in some way. So from first principles, they solve exactly that problem or that challenge, and were a great way in the end to build something like that to empower people in this new age of AI. But then when thinking about it, like how would we actually build it? There was really only one biometric modality that would work, and it's iris recognition. We've talked about that in a different space, and there's also a blog post on this. It, in the end, boils down to what Chris mentioned, is the randomness of the iris structure is the highest, or the amount of entropy in the iris, which helps create kind of really accurately distinguish and verify the uniqueness of everyone to make sure everybody can really participate. Because the problem with like fingerprints or the faces, at some point, the system would confuse new people who want to join with somebody else who has joined before, who is actually not them, and wrongly say that a person can't register anymore as a unique human, which of course is problematic. So only the iris would work. But then even for the iris, we figured in the end, we need to build a custom hardware device. This, I'll be honest, was not by choice, really. It's very hard, it's expensive, it's very time consuming. So not a casual Friday evening decision. But in the end, it was, from first principles, the only reason to build something that would work on a global scale. It took us a while, but today we're there. It's like Orb is, of course, still continuously improving, but it's in use. And people can verify their humanness and their uniqueness in a privacy-preserving way. And the reason why one would need custom hardware is, one, as I mentioned previously, is the highest accuracy is really important to make sure to build the most inclusive mechanism possible, to make sure that really everyone can participate and the error rates are as small as they could possibly be, to hopefully eventually include everyone. The second part is security, and then the third one is privacy. So for accuracy, it's all about imaging and high performance compute locally on the device, run several AI models in real time, as well as in post-processing steps. Second part on security is, one is by building custom hardware, we could integrate several high-resolution multispectral sensors that are only used for humanness verification. Everything can be computed locally. No image needs to leave the device, but they allow for very high security humanness verification. And then, of course, like tamper protection, etc. And then the last part is privacy, and having very high power local compute enables us to compute almost everything locally, such that, as I mentioned previously, that no images need to leave the device. And we can, for everyone who wants to do that, only submit an iris code that then gets compared, as Chris mentioned previously, against other iris codes that have previously verified their humanness and their uniqueness.
Excellent. All right. Thanks for that. So the last kind of point you touched on there was privacy. And we'll wrap up the space by talking about a couple aspects of privacy. One is iris biometrics in general. So there's many biometric modalities, as Chris called them, like fingerprints and palm prints and iris and DNA, for example. So how are iris biometrics, nothing to do with the Worldcoin project, just iris biometrics in general, privacy preserving? So Chris, what do you think?
I think there are multiple answers to this question and multiple ways why we say private, like iris recognition is privacy preserving. And first and foremost, it's because of this one reason that Sandro just mentioned. There is no raw image needed to do iris recognition. And we also don't use any raw images in the end to do the uniqueness check. And if you think about the numbers, an image is a couple of megabytes. The iris code is only just a couple of kilobytes. So it's 3 magnitudes less in terms of like data that is needed. So obviously we are losing a lot of information in the process when we extract the iris code, which also means that we only extract the information that is really needed for identification. Now there is also like a second point, which is in my opinion the way stronger argument and also the more scientific argument, which is again about the randomness of the texture. From a biological perspective, where does this randomness come from? And it's basically tied to the development of the iris structure during the process of gestation. So in the first 4 or 5 months of gestation, this iris texture of every human is developed in a completely random process in a way that it doesn't contain any personal information whatsoever. So a typical counterexample is like DNA. DNA is a very accurate biometric identifier, but it also carries a lot more information than that. For instance, like genetic relationships or so. And as I said before, two iris structures or textures are completely different if you compare them. And that's also true for like this example. If you were to compare the iris texture of my mother with the iris texture of myself, you won't find out that we are actually related. It's a completely different story if you would take DNA, for instance. Then there is actually a third very strong argument for the privacy preserving nature of iris recognition. It is that the user needs to be extremely cooperative. So to capture some high resolution iris image from a user, you need the user to stare into some device which is rather close to your iris and that has a pretty strong IR illumination. And this is something that is extremely hard to do if the user shouldn't notice that. So you really need a cooperative user to basically capture a good high resolution iris image that you can use for like global uniqueness checks. And also there is like a counterexample. Just think of fingerprints. Like whenever you go out to some restaurant and have some nice dinner, you will leave like tons of fingerprints everywhere all over the place, which is definitely a counterexample. That's definitely not true for iris recognition and for iris patterns in general. And I'm pretty sure there are countless more reasons why you would say iris recognition is privacy preserving, but these are my top 3 arguments, I would say.
Okay, sounds good. Yeah, and in the case of like DNA, for example, I don't know if anyone's ever done like an Ancestry or a 23andMe or any of the DNA analysis kits, but there's so much information you get back, like whether you're susceptible to migraines, you forget like heritage, for example, of course, but do you have a predisposition for migraines, or are you going to be good at math or whatever the case might be? But yeah, so great analogy there, Chris. Okay, so we talked about iris biometrics and privacy. Sandro, back to you and the orb. So how does the orb and World ID by proxy preserve privacy?
Yeah, so one really important point beyond what Chris mentioned is all the way in the beginning of the step is when acquiring images, processing them, etc. This all can happen locally on the orb. Per default, no image needs to leave the device and only the iris code needs to be compared against all other iris codes from people who've verified their humanness and uniqueness before. So that's one very big point. And then later on, like the first step is the orb, then like the iris code step that Chris described. And then in the end, when the uniqueness verification was successful, people are issued what we call a World ID, so that people are empowered to prove that they are unique and human online in a very privacy preserving manner. How that works is through zero knowledge proofs, people can prove to different services that they haven't registered before, that they're human and unique, but without revealing anything about themselves. Not even like a unique number or something that could be used to track someone across different applications, etc. But there's nothing revealed about that person because of zero knowledge proofs. And then generally on the protocol side, the protocol is also designed in a way that there's nothing else like publicly linked there as well. So it's two very strong mechanisms to protect privacy. In fact, like this was a kind of like a core principle when designing both the Orb and World ID. Kind of like privacy by design was an incredibly important guiding principle for us. And it might sound counterintuitive, or at least like we encounter that perception in many conversations that, wait, biometrics is privacy preserving? It actually is. It's one of the most privacy preserving ways to authenticate when done properly, of course.
All right, very good. A quick reminder on questions. We're getting close to wrapping up here. So if you have any, get those in the Twitter thread now. But yeah, I just want to also echo something Sandro said about World ID and the protocol and privacy. And privacy by design, if you're not familiar with that, is you build in privacy to what you're doing, meaning you don't have to restrict it after the fact. By design, it has privacy built in. So for example, in two cases, one is not linking any information like iris code to, we won't go deep on the protocol side in terms of zero knowledge tech, but not linking anything about your wallet, for example, with your iris code, with your keys that control your World ID, essentially to prove you're a unique human, by the way, which is what we care about. We don't care who you are, but just that you're unique. You essentially on your device generate a zero knowledge proof that you know the private key to a public key in a Merkle tree, essentially. And that's all we care about, is that you're just unique and that you can do that. There's some techniques with zero knowledge tech, like the use of nullifiers, so you can participate in a vote and then the next vote that comes up in a DAO, for example, or you can participate in an airdrop where you claim it's a monthly thing or whatever the case might be, depending on the application, this month and then next month, etc. Anyway, privacy built in from the ground up. Yeah, so let's see. Question from we have one question that's come in from the audience, Harmonica, if I'm pronouncing that correctly. I think that's correct, Harmonica. We were wondering if Worldcoin could be integrated on a nonprofit community platform, like harmonica.org, and that's HARMONIQA.org, or is it a standalone application? Yeah, Sandro, Chris, if you want to chime in, I can answer that one too as well. Whoever would like to take it.
I think you're actually best at this, Stephen. You're
okay,
closest.
All right.
Go for it.
So the answer is a definitive yes, it can be integrated, and that's actually how it's designed. We have an SDK that for that very purpose is like integration with other applications. And in fact, we're building a protocol to be integrated with chains beyond just Ethereum and Optimism and Polygon for that matter. But you can go to worldcoin.org/world-ID, and we have a waitlist for the SDK. If you want to join that waitlist, then we can notify you when it's ready. It's been a controlled release is a better term. So we just roll it out, making sure that we've got the resources to support early partners and early users of the SDK. So more than happy for you to join. Again, that website, worldcoin.org/world-ID, to join the waitlist. Yeah, so that was the only one, and we're getting close to time, so I think we'll give everyone a couple minutes back. First of all, thanks everyone for joining us. Thanks for the interest. I want to thank Chris and Sandro for being on the call today. I host a lot of these, but I do so because they're fun and I always learn a lot. Again, thank you both for joining. It was great talking with you again. I like these because it's like we're sitting around the conference room in Berlin or something and catching up. But anyway, hope everyone has a good rest of the day. And yeah, we'll talk to you down the road. Thank you.